Step 2 says to place the boundary on the number line using a solid dot to show inclusion, an open dot to show exclusion. Well, notice that we will use inclusion this time because I include my boundary. The little equal says include the boundary. So let's place 5 on the number line using a solid dot. So I'm going to put some of the numbers on here. Here would be 0, 1, 2, 3, 4, 5, 6, 7, 8. And of course, the dot, dot, dot means it continues infinitely in all directions. So I need to place 5 on the number line. So here is 5. That's 1 and 2. 3. So you got 0, 1, 2, 3, 4, 5, 6, 7, 8. So I put a solid dot on the number line at 5. And notice the boundary breaks the number line into 2 regions. The region below 5 and the region above 5. Step 3 says choose checkpoints from each region and substitute into the original inequality. So I put the original in red to emphasize you go back to the original inequality once you choose your checkpoints. So it doesn't matter what you pick as a checkpoint as long as you pick one that is left of 5 and you pick one right of 5. Since 0 is a pretty easy number to work with, I'm going to pick 0 as one of the checkpoints, and I think I'll pick 6 as the other checkpoint. So the checkpoints that I choose are 0 and 6. Now you can choose any of them left of it or any right of it. But you must choose one from the left, one from the right. But that's all that matters. Now once we choose the checkpoints, then we substitute into the original inequality, which is 2x subtract 4 is greater than or equal to 6. I replace the x with parentheses, and here I'm going to substitute in 0. In this one, I'm going to substitute in 6. So I substitute each of my checkpoints into the original inequality. Now we simply work it through. Now 2 times 0 is 0, so 0 subtract 4 is greater than or equal to 6. Negative 4 greater than or equal to 6, which is false. So I got a false on this side. 2 times 6 is 12. Subtract 4 greater than or equal to 6. 12 subtract 4 is 8 greater than or equal to 6. So 8 greater than or equal to 6 is true. So this side gave me a true. Step 4 says shade the true region. So shade the true region. So go back up and I shade on the true side. So start at my boundary and I shade on the true side. So we can see that x is greater than or equal to 5. X is 5 because I include the boundary or anything greater than 5. Now there is a special way of writing that. One can write the solution as 5, comma, infinity. Now let's think about what this notation means. With this notation, the first number tells me where to start. The second tells me where to end. A bracket implies inclusion. A parenthesis implies exclusion. So this says start at 5, continue all the way to infinity. Now infinity is not really a number, but this symbol says that you continue forever. So I start at 5, I continue forever, I do include 5. Now since there's no definite number here, obviously we can't have inclusion. So with infinity or negative infinity, you always have parentheses. So start at 5, include 5, continue to infinity. That's exactly what it says here. Start at 5, include 5, continue forever. Again, where do we start? At 5. I include 5. I continue forever. Let's look at another example. Let's solve x squared, subtract 3x is less than 4. You've seen this one before, but this time let's get an actual solution for it. Step 1. Solve the related equation, which is going to be x squared minus 3x is equal to 4. So just replace the inequality with equals. And that would be the original, that would be the related equation. Now we need to put this in standard form to get x squared minus 3x minus 4 is equal to 0. We can solve this quadratic equation by factoring. I can factor it as x minus 4 and x plus 1. And of course that product is 0. X times x is x squared. It's going to be a plus 1x plus a negative 4x, which is negative 3x, and a negative 4 times a positive 1 is negative 4. Since I'm multiplying two things together to get 0, then one of them is 0. So either x minus 4 is equal to 0, or x plus 1 is equal to 0. Of course, this is the same as x plus a negative 4 is equal to 0. So I can add a positive 4 to both sides, and I get x is 4. Here I can add a negative 1 to both sides. I get x is negative 1. So that tells me that 4 and negative 1 are boundaries. Step 2 will be to place the boundaries on the number line. So I'll put 0 near the middle. Here is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, and so forth. Now 4 and 1 are boundaries. The next thing is, do I include the boundaries or not include? Well, since I have strictly less than, this says do not include boundaries. So the way I show exclusion is to put an open dot. I put an open dot at 4. And I put an open dot at negative 1. Now, this divides the number line into three regions.